I'm going to show you how you can make your queries up to 1,000 times faster just by clicking a button. And I don't use 1,000 as a placeholder to mean a lot. Not like a lot faster. I mean literally 1,000 times faster. So I'm going to show you how this works with PlanetScale Boost. And you may be thinking, okay, PlanetScale Boost is probably just a cache. It's not exactly a cache. You may be thinking, I bet it's a materialized view. It's not exactly a materialized view. It is instead a secret third thing, which I'll talk about in a little bit. I will tell you how it works, but first I want to show you that it works. So I have a PlanetScale database here ready to go. And when it comes to PlanetScale, a regular database actually has quite a bit going on here. So we've got our load balancers that are available across many zones, then our primary and our 2 replicas. So that is our simple database that PlanetScale has deployed for us. Now let's hop over to Table Plus and let's poke around and see what is in the database already. For this demo, we've got 2 tables that we're working with, a repositories table and a stars table. It might remind you maybe of a large code hosting platform. That's merely coincidental. So let's take a look at the structure of these tables. Let's do show create table repositories and take a look at that. The tables here are going to be very simple because the point is to watch this query execution speed. So the tables are very simple and we've filled it up with a ton of data, but there's not a lot of interesting stuff here. We've got ID, name, URL in the repositories table. That makes enough sense. We'll do show create table stars. And this is similarly very simple. You'll see that it's mainly just a table full of references to other tables. So we have the user that starred the repository and the repository that was starred. That's basically it. Here's the query that we're going to be running. We're going to select all of the repositories and aggregate the star counts and join that in. So if we run this, you'll see that it does take a little bit of time, but we do get the results back. So we get the repositories with their URL and the star count. And if we run that again, you'll see that it looks like it's averaging about 750, 800 milliseconds. So this is the query that we're going to be using to test, but I don't want to just run it over and over and over again. So I built a little demo to run it for me. Here's our query again. I'm going to hit save and run. And now what this demo is going to do is this is going to run the query over and over for me. And it's going to plot that response time on this chart over here so we can watch it go up and hopefully go down when we hit this boost button. You'll see down here that we have the query, the results, and the query duration, which is still hovering around 700 to 800 milliseconds. I'm going to simulate activity, and what this does is this starts to churn through some stars. So it simulates users starring and unstarring things. You can see the star count over here is we've got about 1 million stars, and then it drops back down. So with this query running, what we're going to do now is we're going to enable PlanetScale Boost, and it's going to give us up to 1,000 times improvement by just hitting this button right here, and we should see the query time fall off a cliff. So it drops down to 18, 17 milliseconds, and if we disable boost, it's going to go right back up. And you can see that this data is still live down here. This data has been live the entire time. If we enable boost again, it's going to fall off a cliff, but the data stays live. We're not reading some stale cache. These values are being updated when the data is written, and so when we read it out, it is fresh. Now you may be thinking, hang on, let me do the math. 18 milliseconds, 800 milliseconds, that's not exactly 1,000 times. That's more like 40 to 44.4 repeating times. You're correct. Shame on me for telling you I was going to show you 1,000 times and showing you a 50x improvement. How embarrassing. Let me show you a 1,000x improvement. The problem with showing 1,000x improvement is that first unimproved query, it's going to be super slow and it's going to make for very boring television, but we'll figure a way around it. I do want to show you that it does work. So I've run select counts from stars off camera because it took 26 seconds to run, and the number we got back was 28 million. So this is a different database, same structure, but we were working with 1 million stars. Now we're working with 28 million. And I just filled it up until it slowed down enough. So we've got 28 million stars here. I'm going to run this terrible query over this 28 million row table, joining it all together, and it's going to take a very long time. So I'll try to sit as still as possible, but I'm going to fast forward so that we don't have to watch the whole thing. You'll see the time down here at the bottom. Okay, here we go. 55 seconds. It finally finished. Hopefully in the final cut of this video, I made it a lot shorter, but it took 55 seconds. At 1,000,000 stars, I think it was 700 milliseconds. At 25 million stars, it's 55 seconds. This is a great example of a query that maybe works in the beginning, but as you grow, it becomes just completely untenable and a showstopper unless you can click a button and make it 1,000 times faster. We're going to do that by enabling this boost cached queries variable. This is what that button in the web UI was doing. It was just flipping a variable, telling PlanetScale, hey, run this one through Boost. That's all it was doing. So the implementation on our side, on the application developer side, is very easy. We just say, please use Boost for this query. So if we turn on Boost and then we run this again, we're going to see 1,000x improvement. There you go. So we can run this again and again and again, and it's running through Boost now. So instead of taking 55 seconds, it's taking something like 15 milliseconds. So that is PlanetScale Boost improving a query 1,000 times. Now that I've shown you that it works, let's talk about how it works. Here we are back on the dashboard with that overview of all of the infrastructure that goes into a single database. This is actually not what we're going to look at though. We're going to look at the Boost tab. And if we switch over to the main branch, you'll see something that looks familiar. This is our query. This is our query that we have been working with, and it has been selected. I have personally selected it and said, PlanetScale Boost, I need you to make this faster. I've done everything I can. I've got indexes. I know all about how to make queries fast. And listen, this one is just not going to be fast. And so at that point, I hand it over to Boost and say, you got to help me out here. And so you can assign certain queries to be boosted. You can assign certain parameter values of certain queries to be boosted. We've got documentation on all of that, and so I'm not going to show you how all of that works, but you can come in here and find your slowest queries using PlanetScale Insights and say, I need that one to be fast. Sure, maybe it's fixable. Maybe I could re-architect my entire application, or I could just hit a button. Maybe I could just hit a button and make it go faster. You can assign a certain amount of memory per query. So you can say, this one, I want to assign just a little bit because I'm maybe going to add a parameter to that one. And this one needs to be a lot bigger. So you can assign it in chunks however you want. And then once you hit that button, once you hit that add query button, then Boost takes over and those queries become almost instant. Now the question is, how? How does that actually work? I have told you that PlanetScale Boost is not just a cache, it's not just a materialized view, but instead a secret third thing. The secret third thing that it is, it's a partial materialization engine. It's a mouthful, a partial materialization engine. If it were just a cache, we would really have to worry about cache invalidation of your query results. If it were just a materialized view, it would be incredibly expensive to continually recalculate that as new data is coming in. If it's just a virtual view, well, we don't even really get anything in terms of performance. So it is a partial materialization engine, and importantly, the values in the cache, so it is storing that data in a cache, the values in that cache are being updated every time you write to the database, which is what makes those reads so fast. So we need to talk about how that works just a little bit. We have a full blog post on the technical deep dive behind how this works, but I'm going to describe it to you just a little bit. The first thing that we need to understand is that PlanetScale is powered by an open source database called Vitess. So Vitess sits on top of MySQL, and it does a lot of the work at the Vitess layer to figure out where is all the data, how do I go get it, how do I aggregate it, join it, that kind of stuff. One of the things that Vitess layer does is it writes a query plan. So your SQL comes in, our stars query comes into Vitess, and Vitess looks at it and breaks it apart and says, all right, I got to figure out what we're doing here and where do I go to get the data. So it is, one of its core features is writing a query plan. Now, what we can do is we can take that query plan and invert it. So we're writing the query plan to get the data out, right? We can invert it using a lot of very hard computer science. We can invert it and say, how would the result of that query change should someone write data to the underlying database? And so what we can do is we can subscribe to those changes, we can subscribe to those writes, and we can change that cached value whenever someone writes to the database. So we take that query plan used to retrieve data, we invert it, and then anytime someone writes data, we can update the value in the cache. And then when you query a boosted query, it's instantaneous and it's up to date because it's coming out of the cache, and the cache was updated at the point the data was written, not at the time that you're reading it. So that is how PlanetScale Boost enables those queries to be so fast and have the same latency as a read replica. We're talking like 1 or 2 seconds instead of going to something in the cache that's not there and having to execute the query. It doesn't do that. The value is updated when the data is written. I would encourage you, go read the blog post. The blog post is amazing. It's a very technical deep dive. We have a product announcement post, but we also have the technical deep dive on how all of this stuff is done. And it's incredibly interesting. It's got charts and graphs and data flow diagrams, all kinds of stuff that you will enjoy. If you need to boost your queries by up to 1,000 times, go check out PlanetScale, planetscale.com. If you need a modern MySQL database platform, go check out PlanetScale, planetscale.com. See ya.